Excellent. Thank you for coming out today. My name is Akshay Aggarwal. I come to you all the way from Seattle, so half the way across the world, and this is apparently around the time that I wake up every day. So you guys have seen me before my first cup of coffee. Essentially, what do? I don't build APIs. So I'll be honest with you, and I'm going to tell you that I don't build APIs. I take them apart. So 3 things that are going to be interesting for you to know about me that will help you guide us through this conversation, and that are important in this conversation. First, I got my start as in the security business when no one would pay you for security. So we essentially went about doing it in gratis for people. And I spent most of my career helping large organizations like financial services and others think of security at scale. Specifically application security at scale. So what happens when you go from 100 people to 20,000 people or 50,000 people who are actually building software for you, right? And the third big thing that you want to understand is that I come from Seattle. We are, in some senses, one of the big hubs for the cloud, and a lot of things to do with APIs. So with those intersection of security and APIs, we've had some very, very interesting encounters over the last few years, helping companies essentially scale out their cloud applications, and specifically what's happening as they come in and look at new technologies, including GraphQL and some of the others. So I want to take you on that journey, but from a DevOps perspective. So why is API security important in the first place? So if we ask, if we ask any of these companies, including Nissan, Nissan Leafs are fairly popular, at least in the Pacific Northwest where I come from, and you could have gotten into anybody's Nissan Leaf or essentially disable its braking system with an app on your phone, courtesy of that API to manage the Nissan Leaf's output. Similarly, when I was making these slides, they announced a vulnerability in the Android Oreo devices. Instagram and got you more of, allowed you to see more of Justin Bieber than you ever wanted to see because of an API issue. So I can go down this list. It gets worse and worse. And my favorite is that just at the bottom of this list, which is the FCC. The FCC, the Federal Communication Commission, thank you very much for Commission, essentially allowed you to publish whatever documentation you wanted on their website because of an API. Now, who wouldn't want that, right? Because I certainly would. It helps me win a lot of bets. So my entire conversation with you today is this. If you go to programmable web today, there are 18,443 APIs, I think, that they mentioned just before this talk. They expect these to grow up to 1 million public APIs by 2020. So a number of people are going to be writing a lot of code to make that happen. But if you add to this all the private APIs that people aren't talking about, that's 50 to 100 times off that particular scale. In the CI/CD environment that we live in today, you're essentially deploying 6 to 10 releases of every API every year. So my question to you is, how exactly are you planning on securing, do the math on that, approximately 1 billion-ish versions of APIs being deployed continuously? How are you planning to do that? How is your organization actually planning to do that? So if you're doing 1 or 2 APIs, I don't really have much to add to that conversation for you. But when you're looking to go from 2 to hundreds of APIs, both including your public and your private APIs, that's when you want to start thinking about this issue. Now, add to that the complexity of actually having microservices. So as soon as you enter in the microservices architecture world, the complexity of this problem just explodes by an order of magnitude or more, right? So you guys don't have to tell me, but I see a lot of heads nodding in the audience. Wow, I really do need caffeine. And so it seems like people have been facing some of these issues. We've seen a lot of this, right? In fact, OWASP did a study last year in which they asked executives who are responsible for security or for API strategy, who's responsible for that security, and that's the split. 47% of them said it was the developers, and 53% said it was security, right? The problem essentially is this. Currently, securing web APIs at the application layer is slow, it's manual, and you have to rely on a tester to do this. Now, go back to that scale slide that I showed you and think through that. How are you going to scale that one guy or those two guys, or if you're really, really lucky, 5 guys that you have to do this across your environment for every build that you have? Specifically, what is your plan to find the unknown vulnerabilities in your code or your APIs, right? Because a lot of scanners out there will go out and look for what's already known, but as the security guy on the other end or the attacker on the other end, I really care very little about the known vulnerabilities because I'm going to use unknown vulnerabilities on you. So how can you make security be seamless for your developers? I'll talk to you about a few different instances where we've seen that happen. And as Philippe talked about a little bit earlier today, do you have actionable data? So specifically from a log perspective, do you actually have data that will help you pinpoint the problem and then solve the problem? Right? Because that is a significant issue for you, especially as you scale out and if you have very coarse-grained data, then you're not going to be able to pinpoint the problem really quickly. You will be able to do that if you have 1 or 2 APIs that you're looking at. But when you reach the hundreds of API levels, you're not going to be able to do that. Also, $4,000 average cost to fix a bug. We went back and looked at our own data, and we're going to be publishing this in a bit. Our internal data tells us that within a certain segment of customers that we work with, it tends to be between $5,700 and $7,800 based on some assumptions that we've made. So specifically, the challenges to scaling API security are, from a DevOps perspective, API security relies on the developer or the consumer of the API to be responsible for the security model itself. So there are a lot of assumptions that are made by the development team, a lot of assumptions made by the consumer of the API. Very often, those assumptions are not the same assumptions. Very often, the assumption is the other guy did the right thing, so I don't have to. Right? We see that across the board. Again, the increased amount of complexity, specifically in the microservices architecture world. I was sharing this anecdote with in a conversation yesterday that very recently I came across a call chain that was 27 calls long. Right? So, don't even think about the performance issues associated with it. How exactly are you going to find out in those 27 calls, handling extremely complex functionality and having access to sensitive information, what happened that caused the issue at that point? And then specifically, how do you automate testing? So a few key concepts. So as we heard about earlier today, there are a number of different foundational issues with security in the API space. So network security, key management, identity, if you use containers, security of the containers. I call them foundational issues. They're the same, but in a different perspective to the infrastructure issues that you've been dealing with for a while, right? That is not what I'm going to be talking to you about today. What I'm going to be talking to you about is actually builds from what Matt was, on top of what Matt was talking to you about. I'm going to be talking to you what happens after that, right? So I'm going to be focusing on the app and logical security behind APIs, because that is now being spread across multiple different endpoints, and you need to be able to understand how do you find issues that are that cause vulnerabilities within that particular architecture. So if you were to look at this subway map, essentially, what we want to do is we want to inject automated API security testing somewhere in the QA process. And where we're recommending that you do that is right around when you're doing unit testing, right? And I'll talk to you about the benefits of why that is interesting. So to understand the complexity of API security, this is essentially a call graph of why doing API security is very difficult to do. This was in the release candidate for the OWASP top 10 before they went back and started rethinking some aspects of it. But specifically, what I wanted to point out in this is what they talk about is that dynamic and sometimes even static tools don't work well on APIs, and they can be difficult to analyze manually. So these vulnerabilities are often undiscovered. And that's really the problem in this particular space. So based on our work in the cloud space with a number of different customers who do this at scale, we boiled the solution down to a 3-step solution. The first is whatever security solution or process or tool that you use has to integrate within your CI system. You have to be able to test each build, because you cannot take you cannot with the velocity of deployment, you cannot focus on a manual pen test every once in a while to make you secure. And the third thing is that you have to be able to return actionable results to either the QA person, the developer, or the security person. So these are the 3 rules that you want to follow to make sure that whatever technology that you're using actually is helping you. So in a particular instance, with the financial services, with a large financial services organization, this is how it may look like, right? So one of the things that we ended up looking at is how can you utilize unit tests themselves to consume them and then to create security tests from those unit tests so that you don't have to do any additional work in that space. And so the way that we ended up looking at this is this. So we pick up any of the unit or any of the unit tests that you may have written in a particular whatever your testing framework may be. Based on those unit tests, we pass it through a proxy engine. That proxy engine essentially analyzes the payload. That payload is then goes through the engine, and essentially we do a number of different tests on it. We will do some quick boundary analysis. We will do some parameter fuzzing on it, and then we'll create essentially payloads that are supposed to be malicious, right? And we pass those payloads to the target API, and we observe how that target API behaves. And if the behavior of the target API is different than the behavior of the normal test case, then we know that something bad has happened. Then we analyze that behavior, and from that analysis, we are able to detect essentially security issues. Now, the interesting thing about this situation is this. What you've done is you've taken an already produced artifact that you have, which is unit test cases. you have consumed those unit test cases to create security test cases. So one point of friction that you've taken away is that the developer doesn't have to use a new tool. And in fact, the work that's already being done from the perspective of creating a reasonably high quality application is being consumed to drive security testing. You can automate it because it builds into your CI, it plugs into your CI/CD system. And then essentially you can scale it because you can repeat it at any given point of time. In fact, one of the key things that we noticed with this was API parameter discoverability becomes an issue. So if you change the parameter, if you add new parameters to it, how do you discover it? So one of the interesting things that we noticed that came out of the situation was that if your unit tests are robust enough, you're going to be adding unit tests for the new parameters or the changes for the parameters that you've made. And from there, if you make changes to your unit testing, the solution anyways can pick that up. So that was one interesting, robust way of essentially doing away with with having to do any rework, making it seamless to a developer. So from a developer's perspective, let's look at what that may look like, right? So you have a Jenkins. Is this video actually running? Yeah. So from a developer's perspective, you have a Jenkins instance, and in this particular case, this morning I created a pipeline app. What you see in this particular video is that we've essentially created a build blocking step for our security proxy testing engine, in which the test cases get consumed automatically. They get sent out through the build process. The findings come back, and you can look through those findings. Essentially, in this particular case, what we have is we have a clear text authentication issue going through. And so what we've been able to do with this system is really make security just another step in your build pipeline. So the developers never have to see it, and your QA people will just have to go back and look at the bugs. So one of the key things that we realized while we were looking through this process was that anytime you take a developer outside of the tool set that they are used to, the adherence to security and the quality falls dramatically. So the other thing that you'll see is that in this particular system, we end up being able to export all our findings into Bugzilla or Jira or whatever issue tracking system that you may have, so that the developer never has to go outside the tool set that they're already used to. Our observation with some of our working customers in this situation is that their security testing velocity has gone up, their error rates have fallen, and their compliance with respect to their internal processes around security testing has dramatically improved, and their cost has fallen significantly as well. So anytime you're essentially looking at injecting a security tool within your development process, the CI/CD system is where I would suggest that you look at injecting this in. So, in conclusion, what I wanted to focus on was the fact that any solution that you put into to scale out your API security problem, so the solution of it has to match the testing that you're already doing. And that's really the mantra that we want to leave you with, is think of security as not a unique test case, a unique case of testing, but another thing that you have to test for within your existing testing frameworks. right? That's essentially the end of my conversation. If you email me right now, I think my out-of-office message has a copy of these slides as well, and I'll be happy to share them with or answer any questions that people have. Thank you.